Welcome back and welcome in. Tonight, we will drift together into an unhurried story of light and time, a quiet tale about the way a star loosens its gentle hold on itself and slowly grows wide enough to brush the worlds that circle it. If you enjoy these soft journeys and would like more of them, a gentle tap on like and subscribe helps keep this channel calm and cozy. And there is a playlist in the description if you want the learning to continue softly in the background while you drift. How sleepy are you on a scale of 1 to 10? Imagine yourself leaning back into a pillow, feeling the smooth fabric under your cheek and the slow rhythm of your breath humming like a soft song at the edge of awareness. The light in your room is dim, quiet as dusk. You might picture a window, and beyond it, a star that has been there as long as your memory reaches, shining with a steady, patient brightness. The star does not hurry. It has not hurried for billions of years. Its light is the color of sunrise on cool stone, the hue you notice when you are still, and time is wide and calm. In this quiet space, we will travel slowly, unfold a tale that stretches over eons, and you can let your thoughts drift like small leaves on a wide and peaceful pond, circling without effort. Imagine yourself floating just beyond a familiar planet, far from any sound except the faint whisper of a solar wind, a breath of particles from the star. You can sense the star's warmth even here, subtle and even, like a hand near a lamp that has been glowing for a long, unbroken evening. The star's energy has been born deep within, in a central region where matter crowds into itself with patient weight, and where helium ash collects like soft grains at the bottom of a quiet hourglass. Gravity holds everything together, pressing inward with serenity, while outward pressure from the smooth fusion of hydrogen steadies the shape. For an unimaginably long stretch of time, the star maintains a balance, like a tranquil lake that keeps its surface level despite small breezes gliding across it. This is the main sequence, a period of dependable light and warmth, a time when planets, rings, and dust all settle into habits. You can let your attention trace the slow path of light from the core to the surface. Photons are born in bright crowding, but their journey is not straight. They wander, a leisurely dance over lifetimes long beyond words. They bump and pause and scatter, a gentle ballet that eventually carries the energy outward. When they finally reach the surface, they flow away, spreading across space in soft waves, cooling slowly as they travel. Your eyelids may grow heavier here as you picture a star breathing in an incredibly slow rhythm, almost too slow to notice the rise and fall of energy across an ocean of time. The gentle rhythm continues. Now imagine that time, already vast, becoming vaster still. The star's core, remorseless only in its steadiness, builds up helium, the ash left behind by hydrogen fusion. The hydrogen in the center grows sparse, stretched to its limit by patience, and the core loses a little of its outward push. Something subtle begins, like a whisper at the edge of a quiet room. Gravity draws the core inward, not fast, not rough, but with the kind of steady, unerring motion that happens over tens of millions of years. As the core contracts, it warms. Heat is a kind of pressure, and it tries to push back. Around the core, in a surrounding shell where hydrogen still lingers, fusion lights again with new vigor. It is as if a ring of fire forms outside a settling ember, a broad, quiet furnace that burns the hydrogen just beyond the center. The outer layers of the star respond to this shift the way a warm loaf of bread rises with slow assurance. The atmosphere expands, the radius increases, the surface cools, not to the touch, but in color, leaning toward copper, with a luminous hue that spreads comfortingly across the spectrum. The star grows larger, and its light, while cooler in shade, spreads over a larger area, so the total brightness increases. Seen from a quiet vantage point near a circling planet, the star becomes a gentle giant, its disk broadening over long spans of time like a lantern globe that slowly inflates and softens the room. You might notice as you lie back and breathe how the word giant feels big and heavy. The scene we are building remains gentle. The expansion is not a leap. It is a slow embrace that takes millions of years to reach new distances. The surface layers of the star are now a vast, tenuous sea of large and light. If you could wade into this atmosphere, you would not meet a wall. You would find a feather-soft gradient, a thinning presence, where particles are far apart and in constant quiet motion. The outer layers are convective, like a pot of water warmed from below, but the boiling is not harsh. It is a rolling, heaving, transporting motion that cycles heat outward and brings cooler gas inward. The convective cells are large, spanning fractions of the star itself, and if you could see them from afar, you would notice patterns that slowly change and drift, as if clouds were embossed on the star's glowing surface. Now, consider a small world close to the star. It has circled faithfully for almost all of the star's life, following the same track like a worn path in a familiar field. The world has its own rhythm, its own tides and winds, its own gentle seasons, set by the distance to the star, by its tilt and spin, by the pull of neighboring bodies. As the star swells, the light increases, the world warms. Subtle changes begin earlier than you might expect, thousands of millennia before any true contact. If there are seas, they become broad mirrors of heat, water simmering slowly under a sky that glows a soft amber. The atmosphere thickens with vapor. The clouds rise higher, reflecting some light, trapping some heat. On such a world, daytime becomes a bright haze, and night no longer cools as much as it used to. Winds weaken in some places and grow in others, reshuffling patterns that had persisted for ages. Nothing happens abruptly. The gentle rhythm continues. On the star itself, the core grows denser. For stars like our sun, the helium core becomes degenerate, a special state of matter where pressure resists compression not through ordinary heat, but through a quantum firmness woven into electrons. In silence, the core intensifies its internal energy. Around it, the hydrogen-burning shell feeds the star's brightness, while the outer envelope responds by swelling further. The surface temperature declines toward a pleasant red, like the color of iron warmed in a hearth, but not flushed, or the last light of dusk lingering on a sandstone canyon wall. If you picture the sky from a small rocky planet that remains outside the swollen atmosphere, the star would appear several times larger, a smooth disk with a faint textured limb, its color calm and coppery. The dawn arrives sooner, and the twilight lingers longer, because the sun takes more of the sky and rises and sets with a measured, stately glide. Around many red giants, we see signs of change that drift outward like a slow breeze. Mass loss begins. The star's atmosphere, loosely held by gravity as it expands, allows a persistent wind to carry material away into space. Starlight pushes gently on particles, and dust condenses in cooler regions where the gas has time to gather into tiny grains. The wind thickens, building and building over long periods, becoming a steady outflow that can send entire Earth masses into space over spans of time, so long they feel like the deep, even hum of a distant machine. This outflow changes the gravitational grip of the star ever so slowly. The orbits of planets respond by drifting outward, expanding like spirals drawn at a calm, measured pace. Farther worlds may escape the star's embrace by slipping to wider tracks as the star's mass ebbs, while closer worlds feel another influence rising, a tidal tug and a frictional brush with the star's extended atmosphere. Tides are a gentle phenomenon by nature. There is nothing explosive in them. They are simply the tendency of gravity to pull a little more on what is close and a little less on what is far, stretching objects like a soft lump of clay pulled by a slow pair of hands. When a planet orbits a swollen star, tides raise bulges on both bodies. The star, with its large convective envelope, shifts, moves, and stirs in response. The planet feels the pull as a torque that can slow its spin or speed it, depending on how the bulges align with motion. Inside the star's envelope, viscosity and friction dissipate energy, and that energy goes into heat. Over time, the orbit can change. When mass loss and tidal drag balance, the orbit might hover. When one dominates, the planet creeps outward or inward. If the expanding atmosphere grows so large that it grazes the planet's path, the planet begins to move through a thin, velvety medium. This is not like plunging into water or air as we know them. It is more like drifting through a wispy fog that still has the power over ages to slow a traveler. The planet's speed drops a little with each pass, and the orbit tightens, spiraling inward at a rate that could take 1,000,000 years or more. In the language of calm, this is a slow embrace. The star-score's patient expansion meeting the planet's quiet inertia and drawing it toward a common envelope. You can let that image settle, like a leaf that takes its time to touch the surface of a pond. There is harmony in the math, and there is a hush in the reality. The planet may glow as gas in the star's envelope warms its surface. It may lose any remaining atmosphere to the star's breath. If it is small, it may dissolve into dust and ions that join the star's skin like snowflakes melting on a warm sleeve. If it is large enough, like a gas giant with a dense core, it may sink inward slowly, transferring angular momentum to the star's outer layers, bending those layers up a little, stirring the star's envelope like a slow spoon in a tranquil cup. In that stirring, elements can mix, and astronomers, peering from far away, sometimes find signs of such events, little enrichments in the star's surface, hints that a planet once passed this way. even the glow can shift. A star that has recently welcomed a planet can show a subtle warming of its surface, a brief brightening that lingers and then fades back into the general red of its age. In the far future of a sun-like star, there is a moment of inner change that still arrives with the serenity of long time. The helium core, having grown hot enough, begins fusing helium into carbon and oxygen. For a star with a degenerate core, this ignition is sudden in a technical sense, but even that suddenness plays out beneath a massive envelope that smooths the experience, like a thick blanket that dampens a bump on a bed. Observed from the outside, the star's brightness and size adjust on long arcs. The star settles into a quieter phase, smaller and less luminous than at the tip of the first giant branch, but still large and calm. Later, the shell burning resumes its layered dance, and the star can enter the asymptotic giant branch, expanding again, producing a thicker wind, growing more benevolent in the way it returns its matter to space. The outer layers, now rare and slow, drift away in a long exhale, shaping a halo we will one day call a planetary nebula, a name that is itself a calm misnomer from an earlier era of soft lenses and gentle language. The destiny of each planet in this gentle theater depends on details of mass, distance, and the star's own quiet decisions. A tiny world very close to the star rarely resists the slow tide. Its orbit, once a neat circle, becomes a slowly shrinking spiral. It turns through a soft soup of coronal gas near the star's edge, warming the thin atmosphere nearby, producing a trace of light that is easy to miss. The end is not an ending in the cinematic sense. It is more like a seamless blending, with its substance returning to the star, its identity diffusing until it is all part of the same calm glow. A larger world farther out may survive untouched, though bathed in a stronger light that changes its mood and reworks its weather. On an icy moon of a distant giant, that new warmth could melt ancient frost, perhaps building seas under shells of ice, transient oceans in hidden places that rise slowly and linger for spans long enough to matter to the materials themselves. The gentle rhythm continues. You find yourself drifting along the ecliptic, looking at belts of dust and pebbles. These particles, some as small as motes, caught in a beam of light in a dark room, feel the star's growing breath as a pressure that affects the tiny more than the massive. Pointing Robertson drag, a soft, steady whisper of photons, slows their orbital dance, causing them to spiral inward like light snowflakes drifting toward a hearth. There is nothing harsh here, just a quiet shifting of patterns, rings and belts, rearranging themselves to the star's new measure. Comets that used to sleep in the deep freeze of a distant cloud may stir when the star's brightness grows, their surfaces warming, their slow sublimation producing graceful tails that arc through a sky that is now bright even at great distances. Little by little, the architecture of the system relaxes into new shapes, with existing worlds moving outward on the ease afforded by mass loss, while close companions accept the soft invitation to move inward, to join the star, to become one with its radiance. If you bring your mind home to a star like our own sun, you can let the timeline unfold in easy steps, no rush, no alarm. For billions of gentle mornings, it stays the same, a pale yellow calm that makes the colors of life glow. Along the way, it brightens slowly as fusion rebalances the core and the habitable zone expands outward in careful rings. Over hundreds of millions of years, the climate of a nearby rocky world warms. Oceans retreat not in waves, but in drawn-out sighs with shallow edges becoming wide plains of salt and mineral. The air's composition shifts as rocks and water stop absorbing carbon the same way, and as the warmth encourages new cycles and ends old ones. In the end, long before the star's red stage begins, that world becomes something else. Still a world, but of a different kind, with new winds and new colors, and the deep hush of a quiet, dry surface under a more brilliant sky. The rhythms of day and night persist, with dawns that glow clear and twilights that carry the music of a warmer air. As the subgiant phase arrives and the star moves up the red giant branch, the innermost worlds face gradual changes in their orbits. Tides and the expanding envelope meet them gently. For Mercury, the track closes like a slow, soft door. For Venus, the path is long but similar. For the Earth, details matter, and scientists trace paths with care, comparing the slow drift outward caused by the star's mass loss with the inward pull of tidal friction and atmospheric drag if and when contact with the star's extended skin is made. Some tracks leave Earth just beyond the star's reach, others invite it inward. The range is narrow and the edge is calm. In any case, the transformation comes after long, steady steps, with no sudden jolt, only the sense of lights dimming into a warm, pervasive glow. The moon's orbit, slowly expanding today, continues to change, yet in the grand finale of the red phase, the geometry shifts. Tides in the star tug and whisper across distances unimaginable compared to any ocean tide you know. The moon's dance with the earth rewrites itself in ponderous verses. The gentle rhythm continues. From the vantage point of an astronomer, the evidence of these slow endings accumulates like pages of a well-thumbed book. There are stars rich in elements that rise to the surface only when mixing occurs, hints that something stirred their layers from within, perhaps during a quiet planetary embrace. There are white dwarfs, the embers left behind when red giants release their outer layers, whose spectral lines carry the fingerprints of rocky matter that drifted in and was tidally pulled apart. Those traces tell of asteroids and minor planets that once orbited far away, but over ages moved inward under subtle drags and gravitational dances to finally lay their minerals onto the white dwarf skin. We see red giants with IR excesses, soft glows that suggest dust has been warmed and re-radiates in the mid-infrared, traces of the material they have let go. There are gaps in the distribution of known exoplanets, zones near giant stars that are curiously empty, as if the planets that would have lived there were invited to a final slow waltz and then merged into the star's muted melody. You can picture, in a serene and deliberate way, how these processes feel if you were a quiet traveler lingering near a red giant's photosphere. The light around you is amber, and it does not glare. It bathes. The star's surface looks soft, almost fuzzy, because the convective granules are large and the edges are not sharp. Eddies drift and evolve, swelling and fading over weeks and months, in cycles that get lost in the length of the star's true story. Inside the envelope, movement is enveloped in buoyant motion. Columns rise and fall, carrying heat outward and bringing matter inward. This mixing can dredge up elements created in deeper layers, peppering the surface with signatures of the star's mindfully assembled chemistry, a gentle handprint that astronomers can read. Because the star is so swollen, the gravity at the surface is mild. Particles can leave more easily, especially if they are invited by radiation pressure on dust grains. The wind, constant and patient, carries whisper-fine material into the wide, dark quiet between stars, forming a flow that can eventually shape shells, yerks, and ripples. Imagine now the moment when the red giant is ready to let go more fully. The outer layers, no longer held as tightly as before, lift and drift, peel off, expand into a sphere so large that it begins to reveal delicate features. The star, now a thin core surrounded by gradually thinning veils, illuminates this shell from within, and the shell glows in soft blues and greens and reds, colors that depend on the ions present and the energy of the photons washing through. This is the planetary nebula phase, a quiet bloom at the end of a long season. The shell spreads and fades, becoming part of the general haze of interstellar space, adding its matter to the common pool from which new stars and planets will be made. The core remains as a white dwarf, an object small and dense, cooling slowly for billions of years, shining with a pure, steady light like a frosty ember at the bottom of a hearth, clean, precise, and calm. Around it, some planets may remain, their orbits widened and stable, circling their old companion as it rests. Others may have been lost, their substance folded gently into the star during the warm expansion era. The gentle rhythm continues. If you let your attention drift across different kinds of stars, you will find that the story remains consistent. While the details change in soothing ways, massive stars move faster through their life cycles, but their red supergiant phases are still broad and calm compared to human time. Their winds can be stronger, their mass loss more generous, shaping complex, beautiful shells and knots. Their endings, beyond the red phase, can involve events that, on human scales, are energetic. Yet, even in these cases, when we speak quietly about the red stage itself, we are speaking about slow expansion, about light shifting to red, about sizes measured in orbits and atmospheres measured in stellar radii. On the other end, for stars smaller than the sun, red phases are gentler still. Their lower masses mean different balances, different lengths, different convective rhythms. But the slow breath is still there. The long patience is still the guiding theme. Consider, too, the way this slow star shapes the zones where a world might be comfortable. The habitable zone is not a fixed ring. It moves outward as the star brightens. Planets that were once too cool may find themselves bathed in new warmth, and moons that spent ages locked under ice may feel a thaw in their outer layers. If there are oceans hiding under crusts of ice, they can stir. Minerals can dissolve. Chemistry can explore. It is a transient gift, but then again, so much in the universe is transient when held up to the longest measure. There is comfort in that thought. It means that any moment of peace we find, like the one we share now, has its place and time to be. It does not need to last forever to have meaning. The gentle rhythm continues. Sometimes astronomers witness a moment that aligns with the long story. A star flushes slightly. Its spectrum hints at fresh lithium. Dust forms quickly in a new plume. The event fits the dance we are describing, and for a brief season, the star tells a more specific story about a particular planet that drifted too close. These are not loud episodes. Even when energy is released, the universe is keyed and absorbing, and the star's slow processes return, smoothing the ripples out as they pass. In the chalk notes of astronomy, on papers that smell faintly of dust and printer ink, the tale of a swallowed planet is recorded with numbers, with velocities and line widths, and equivalent widths with gentle curves that describe light as it rises and falls. It is a quiet literature written by the cosmos in figures that rest politely on pages while the nights flow on. You might picture a frozen body far out in a region like our Kuiper belt, black as graphite and ancient. For ages, it lives in the dark, with only a whisper of light to warm its face. As the star becomes a red giant, that whisper grows into a low conversation. The surface warms enough to release gases to soften the sharpness. Dark ices become tarry blankets that absorb and re-emit the star's heat. The body spins, emitting a faint plume, reshaping its own path through a subtle effect of jets and outflows. It may drift inward a little. It may capture a companion pebble and share a gentle rotation with it. The new light is a temporary companionship, but it lasts long enough to rewrite this small world surface, to add a veneer of change over its deep, stable core. In the hush of your room, the boundary between the small and the large becomes soothingly thin. The slow expansion of a red giant feels like a magnified sigh, the kind you let out when you finally settle into a comfortable position and feel the day unclench. Planets respond like blankets being pulled slightly closer or allowed to slide softly away. Everything continues to move, but no one is in a hurry. The starlight glows through the atmosphere and into your quiet imagination, bending around the corners of your thoughts like warm light around a door at night. The gentle rhythm continues. You find yourself thinking of the mechanics again, not in a hurried way, not chasing equations, but strolling through them like a peaceful garden. Hydrostatic equilibrium is the balance between pressure and weight. Energy generation in shells is a ring-bearing. Opacity changes in a star's outer layers steer energy through different channels, sometimes as radiation that passes, sometimes as heat that lifts and falls. In red giants, the formation of negative hydrogen ions, hydrogen with an extra electron, gives the star its particular way of interacting with light, its way of absorbing and emitting, of letting photons navigate the last soft layers before space. Convection zones expand because radiation finds it harder to carry energy through certain dense, cool layers. The star, in response, chooses buoyant motion over clear radiative transfer, and the surface becomes dynamic in a mild, stately fashion. These are not words to memorize, but rather textures to notice, like the feel of the grain in a wooden banister as you run your fingers along it during a slow walk up a staircase you have climbed many times. On a world being gently warmed during this era, rocks release gases slowly. Volcanoes, if they exist, find different rhythms as the mantle beneath them changes in heat distribution. Atmospheres thicken or thin depending on what is released and what is held by gravity's careful hand. A strong wind across a plain can move dust in a way that paints long, pale streaks across the surface, then stops for a century, then resumes, rewriting patterns that will last longer than cities and shorter than continents. The tone of daylight sets the color balance for everything, tinting valleys and seas with the red's soft thumbprint. The night sky changes too, as certain stars are washed out by the brighter day and others rise more boldly at dusk. Depending on the planet's orientation, sunsets could stretch in time, the upper limb of the star's disk drawing down a long arc, painting the atmosphere in layers of peach and garnet, while the first faint stars appear one by one, unwilling to rush. In deeper time, after helium has been consumed and the star moves through the asymptotic giant branch, thermal pulses arrive like distant waves against a long, shallow beach. These pulses are episodes when helium shell burning becomes more intense for a time, creating a slight expansion and cooling that then quiets, allowing hydrogen shell burning to resume dominance in cycles that take tens of thousands of years. The star's surface, set in motion by these inner moods, sends out shells with varying density. Over the course of many pulses, the star's outer layers grow more fragile, more ready to drift away and join space. When the outer layers finally depart in full, the remaining core floods the shell with ultraviolet light, causing it to glow, to show off curls and knots and filaments that wind through space like delicate lace. Now turn your attention to orbits and to the gentle mathematics of change. A planet's orbit is a balance between the inward pull of gravity and the outward tendency of inertia, the desire to keep going straight. When the star loses mass, gravity softens and the planet's orbit expands. The change is slow, proportional to the amount of mass lost. If mass loss outweighs other effects, a world that once circled at one distance now finds itself farther out, moving more slowly, tracing a wider loop around a star that is no longer as heavy. At the same time, if tides are strong because of proximity and envelope interaction, the friction slowly reduces orbital energy and the track tightens. The fate depends on which effect dominates and when. It is like a dancer's slow pivot, moved partly by the gentle pressure of a partner's hand and partly by a soft breeze at the window. In many cases, worlds just beyond a certain radius will slip outward, while those just within will slip inward. The dividing line is not a razor, it is a band, a place where small assumptions matter. All of this unfolds without haste. The gentle rhythm continues. Some planets, especially gas giants that begin in moderately tight orbits, may experience an especially tender exchange with their star. As they move through the star's outer atmosphere, they can lose some of their own gas, a trail of material that decorates their orbit with a barely perceptible ribbon. But they can also deposit angular momentum into the star, causing the star's envelope to turn a little faster. The change in spin can be detected by astronomers through careful study of spectral lines, their widths and shapes betraying the speed of rotation. After a while, as the giant planet spirals inward, It heats and then may dissolve deeper inside the star. For a time, the star can appear more active, shedding more material, showing chemical signs of having ingested a planet. Then the activity soothes again. The story settles back into the long, slow glow of the red phase's middle years. As the star's life lengthens into its red chapters, it continues to write with detail into the interstellar medium, enriching it with carbon, nitrogen, and other elements formed within. Those atoms drift into space and, over a long time, become part of cold clouds that float between stars. Inside those clouds, new stars are born, and the cycle of balance and burn repeats. Planets gather in disks around newborn suns, an arrangement that someday will feel the same slow changes again. Our story is not the story of one star alone, but of a practice in the universe, a habit it has of turning gas into light and light into calm heat and heat into wind and wind into new gas that knows a little more. There is a quiet satisfaction in that, the sense that every step is respectful and returns what it has used. At this point in our journey, you might gently check in with yourself, your breathing slow and steady, your body fully supported by the bed or couch beneath you, your mind moving at the easy pace of the cosmos we have been describing. Still awake? Comment the secret word, nebula. In this deeply calm space, it is pleasant to visit the way light itself changes as a star enters the red giant phase. The spectrum softens. The peak of emission glides to longer wavelengths. Objects bathed in such light look different, their shadows less sharp, their edges less hard. The human eye, evolved under a yellow sun, sees red light in a way that makes surfaces seem richer and gentler. Plants, if they exist, would work under a different selection of photons, and their biochemistry, if it is possible under such light and such conditions, would write a different recipe of pigments. Minerals reflect differently too. A field of silicate grains could glow with a soft rust tone. Metals might seem more muted. Even ice, if it still exists in places cool enough to resist the warmth, would carry a blush, a faint tint that betrays the shade of the star above. There is a beauty in thinking of the scales involved. A red giant can grow as large as the orbit of a small inner planet or beyond, its radius swelling into what used to be empty space. The photosphere, the layer from which most photons escape, is not a sharp boundary. It is more like the point in a fog where you can no longer see your hand clearly. Beneath that, the density increases smoothly. Above it, the gas grows thinner quickly, but not instantly. The gradient is long and soft. Stars that could fit comfortably within the distance between their center and surface on cool evenings become grand and slow in their red phase, expanding to sizes that we measure in terms of the distances between planets. It is an enlargement without aggression, an opening of space, much like the way a deep breath expands your chest when you breathe in before a nap. You can also reflect on the energy balance of a planet in these calm changes. The warmth it receives comes from the star, and the warmth it lets go depends on its own surface and atmosphere. As the star brightens, the planet's surface and air respond. If there's a thickening greenhouse layer, the surface traps more heat. If there are bright clouds, they can reflect a part of the incoming light. The balance shifts slowly, day by day, and millennium by millennium. The results are predictable in general, but full of small variations. A valley may keep its haze longer than a plain. A sea, if any remained, may take centuries longer to warm and may smooth seasonal extremes. Little by little, equilibrium is found, then moved again by the star's patient steps outward and upward in luminosity. At the edges of the star's gravitational influence, far beyond any familiar orbit, the outflowing wind shapes a bubble in the interstellar medium. The star's wind has a termination shock where it meets the slower, denser material of the galaxy like a river that meets a lake and slows behind a sandbar. In the red giant phase, the wind is stronger, the bubble grows. Dust at these distances cools and glows in the infrared. And if you could view the system from afar with an instrument that sees these long waves, you would notice a faint shell, a soft blur around the star. The structure can carry wiggles, arcs, and clumps that tell of slight changes in the wind over time, of pulses, of influences by orbiting companions. Each signature is small, easy to miss, and yet it is present. A calligraphy written over thousands of years, readable to those who have the time and patience to learn the alphabet of starlight. Sometimes two stars share the red stage, or one star enters it while the other remains smaller and bluer. In these systems, the slow dance becomes even more intricate, but still not rushed. Mass can flow from one star to the other. Disks can form around the companion. Jets can arise gently, sculpting the outflow into long, narrow structures that fan out across space. Planets in such systems experience tides from more than one source, and their paths can be complex, but the timescales remain long enough that changes are not abrupt. Warmth rises and fades, orbits adjust gradually. If a planet finds itself deeply within a common envelope shared by two stars, its future becomes part of a slow spiral inward. But the journey remains measured, covered in the weeks and months of stellar time that are, to us, indistinguishable from stillness. Astronomers tease out these stories with a kind of meticulous calm that matches the subject. They measure radial velocities, watching spectral lines move back and forth by tiny amounts. They count the periodic dimming of stars when planets transit, noticing that older, larger stars rarely show regular dimmings at short periods. They read the fingerprints of elements in stellar spectra, finding enhancements that linger for a while before mixing erases them. They compare populations of planets around stars of different sizes and ages, matching the patterns to models that include tides, winds, and mass loss. Each piece is small, and every conclusion carries margins and caveats, but together they paint a picture that is as clear as any long exposure taken on a quiet mountain at night. Through all of this, the theme holds steady. A red giant is not an event, it is a season. It is a long evening that comes after a bright afternoon, a redder, gentler light that signals a period of change. Worlds respond with humility, giving way to warmth, following the quiet instructions written into gravity and heat. Some slip inward and become part of the star again. Some move outward and watch from a safer distance. Some find temporary comfort in regions that used to be cold. And when the season ends, When the light turns white again on the way to a patient ember, the system settles into a new order with a white dwarf at the center and silent planets, rings and belts gliding around it the way moths glide around a winter lantern, not for warmth, but for the memory of warmth, for the simple habit of a circular path and a reliable center. If you imagine standing on a distant body, something like a dwarf planet, looking up at a white dwarf that used to be a red giant, you could feel a sort of respectful quiet. The light is clear and steady. The sky is black, and the stars are sharp, because the white dwarf is small and brilliant and does not shed a wind the way a giant does. The orbit in which you stand is broader than it used to be, and the day there is the length it has been for millions of years. The ground under your feet is cold, and rocks make faint clicking sounds as they shift and settle. You breathe slowly. The gentle rhythm continues. Now, let your awareness return to the present, to your own room, to the simple feeling of being held by the bed and soothed by the slow breath we share with this story. The universe is wide, and in that width there is room for changes that happen at the scale of comfort, at a pace that nurtures rest. A star grows, and worlds yield softly, and eventually new center forms, and worlds settle again. This is not a morality tale or a warning. It is a description of how things are. Given the laws that fit together like calm puzzle pieces, gravity is a long, patient hand. Pressure is a gentle counter. Light is the relaxed expression of stored energy making its way outward. Worlds are the quiet responders, following rules with grace. Think again of the first thought we shared, the slow embrace of a red giant. Embrace here is not an act of taking, it is an act of meeting. The star reaches outward, its atmosphere becoming vast and soft, and the planets that wind close feel the brush and accept it. Over time, the brush becomes a touch and then a blending. In the soft glow, identities that were separate for eons become one. The elements that had been shaped by cold and rock and atmosphere rejoin the stream that feeds the star's light. And then the star, in its generosity, gives that light back to space, warming other surfaces, filling other nights with a gentle radiance. Those that remain at a distance keep their paths, but absorb the lesson of the new light, adjusting their seasons and colors to the redder tone. Nothing is wasted. Everything flows. The gentle rhythm continues. We can end our watch here, not because the story ends, but because it becomes even slower than before, and because slowness suits sleep. You can let the image of a copper star, soft-edged and large, stay behind your closed eyes like the afterglow of a candle you have just blown out. You can feel your breathing as a faithful tide, in and out, like the silent pull between world and star, moving air in your lungs the way orbits move through time. If you found comfort in this journey and would like more calm voyages like it, it truly helps when you subscribe and leave a like, so we can keep sending these soft stories into your evenings. Rest well, feel safe, and drift peacefully, knowing the universe moves with you in a gentle, unhurried rhythm.